Alright, so today we are going to be looking for some programming problems on the internet. We're gonna try to solve some problems, and I'm going to be improvising all of this. I'm new to this, and I'm gonna keep it simple. I'm gonna be improvising everything, and I'm going to be solving problems in real time, show the process, and try to explain it. Okay, so there are many amazing websites to solve problems. Today is Saturday, and obviously, like any other person, I'm here in the computer solving problems. It's on Saturday, and there are many sites. One of them is this one. Um, I don't know if I can say the names. I'm new to YouTube, so I'm just gonna go and look for some problems here. Let's see, this is an amazing site, and I'm gonna be talking about all of this during the videos. So without further ado, let's just find some problems. How do I do this? Algorithms, maybe. Okay, let's start with something easy, unsolved, of course. Utopian Tree, let's try this one. It's an easy problem. Easy problems are very important. They help you warm up. Okay, so the Utopian Tree goes through two cycles of growth every year. Each spring it doubles in height. Each summer its height increases by 1 meter. An Utopian tree sapling with a height of 1 meter is planted at the onset of spring. How tall would the tree be after n growth cycles? For example, if the number of growth cycles is n equals 5, if it's 5 growth cycles, the calculation is as follows. So at 0 cycles is 1 because it starts as 1. At 1 cycle is 2, 2 cycles is 3, 3 cycles is 6, 4 cycles is 7, 5 cycles is 14. Okay. Okay, so let's do this. I'm going to go here. This is some basic template that they give us. I don't like it. So let's just start from nothing. This is the basic library in C++. I'm gonna do this in C++, but I'm gonna be changing programming language here and there because what matters is not the language but the problem. Okay, so the main function. Okay, so let's try to solve it in two ways. Int. I'm gonna create a find height. So I'm creating a function that finds the height, and what the function gets, it's the int is the cycle. The first approach is very easy. So for int cycle plus plus. So from cycle from 1 to the number of cycles, I'm gonna simulate the growth. If it's even, that means the height increases by 1 plus equals 1. Otherwise, the height is multiplied by 2, and then you return height. Then they give you how many test cases they're gonna test you. So let's say int tests input. This is reading how many tests they're gonna give us. Now we cycle through each test. So find height at that many cycles. So let's run this. Oh, I'm missing something like it. Okay, so run code and It's working for the first two test cases, but okay, let's find a better way though. This because this function is basically order of complexity of n, where n is the number of cycles. This for is gonna iterate for each cycle. So my solution is gonna take at least n steps to finish. Let's find a pattern here. Okay, you want to like patterns? Did you ever had one of those tests that gave you a series of numbers and then you have to guess the next one? Well, this is what it is basically. Look at this. If the cycle is even, divide the cycle by 2, add 1, and take 2 to the power. But we need a function that gets us the power of 2. The exponent of this is if it's odd, for example 7, the exponent will be 5, which is 7 divided by 2. In the computer, when you divide integers, it gives you the smallest part of the divisions. For example, 7 divided by 2 is 3. Okay, so in this case it's 3 and then you add 2. So is the cycles divided by 2 and then added 2, and then after that you have to subtract 2. 2 power of exponent, and okay. So now we have a different solution one, and now I'm gonna submit the code to see if this works. So let's hope that it works, otherwise I'm gonna look like not very smart. Alright, so here it goes. Submit code. The first solution, which is the slowest one. Yes. Excellent. It works. Okay, so it works. It passes all test cases. Now, let's try the second solution. So let's run it on the first test cases. This solution is way faster, but I don't know if it's gonna pass. Okay, so here it goes. We're gonna see if the second solution works. Here it goes, submit code. Yes, works. High five. Good job. When you solve a problem, you should always be happy no matter how hard it is, because it's always an accomplishment. Okay, so now we're gonna go ahead and solve something else. But let's look in another side. Let's look in this one. Again, if you know if I can say the names of the sites, let me know, because I don't know. Let me know in the comments. I'm new in this YouTube thing. I just want to solve some problems, man. I don't know about the YouTube thing. Problems. Give us some problems. This time we're gonna try a medium problem. This is an amazing site, by the way. This is like the number one if you want to prepare for job for software interviews. This is the one site. It's so good. Without further ado, coin change, binary tree coloring game. Let's try this one. Okay. Binary tree coloring game. 2 players play a turn-based game on a binary tree. We are given the root of this binary tree and the number of nodes n in the tree. Okay, so we have the root and number. N is odd, and each node has a distinct value from 1 to n. Initially, the first player names a value x between 1 and n, and the second player names a value y between 1 and n, and y is not the same as x. They name different values. The first player colors the node with value x red, and the second player with value y blue. So this is the tree right here. You have a tree right here, and then the first player picks, I don't know, this one, and it colors is red, and the second player picks another node, whatever node, can be any of those, but in this example he picked this one. Then the players start taking turns. In each turn that player chooses a node of their color, red, red if played 1, blue if played 2. Jesus Christ, what is this thing? The What a weird game. I don't think this is a game that I will be playing with anyone. It doesn't seem like a very fun game, honestly. But solving the problem. Okay, so basically we have, let's say we have this one, this one. All right, so here's the deal. So the first player is your enemy. Okay, this is the first player is your enemy, and the first player chooses whatever node he can. So let's say that he chooses this node. Wham. Which node do you choose in order to win the game? So now you're the blue node. Which node can you choose in order for you to win the game? Well, if you choose this node, he's done, because he cannot color anything else. Um, so now let's say that he chooses this node. Can you win? Well, if you choose this node, it's done. You're done, because you cannot go up because it's red. You know what I mean? Um, however, if you choose, however, if you choose this node, you can take possession of 1, 2, 3, 4 nodes, and he can take possession of all these other nodes. But that's your best bet. So it seems like you have to choose. It seems like you have to choose the. Let's imagine that this is a new tree. I need to think about this more. Okay, so as you can see my clock. So this is in real time. Still Saturday, still January 9th. So always real time problem solving. Okay, so I thought about a different way of seeing this. First, let's just say that your enemy starts first. Your enemy is red, and let's just say that your enemy, this is the tree, and your enemy picks a random. Doesn't matter which one it picks. Your enemy picks a random node. It doesn't matter which node he picks. Let's just say he picks this one. Okay, so once he made that choice, let's see your best options. What are your best options? Okay, so one option is that you pick the node right behind, and if you pick this node, well, you can take possession of all of these nodes in this way, and then the red can take possession of the other ones. Okay, so that's one possibility. What's the other possibility? That you do this, and then you can take possession of all these nodes, and then the red takes possession of everything else. And the other possibility is that you pick this node. Those are your best possibilities. Why? Because if you pick something that's not, if you don't pick anything other than this rightly connected to the red one, you pick this one, for example, then your enemy is gonna quickly do what you were going to do to him. He's gonna do to you. So he's gonna quickly do this. You chose another node. If you chose the blue one here, he's gonna do the same. He's gonna go up and try to block your progress here. He's gonna go up, and now it can take possession of all of this. So the nodes that we care about are the ones that are immediately connected to. Now something else, how many nodes can you get? Well, you have to count how many nodes are the children of each node. For example, this node right here, how many children it has? I mean, how many nodes start from here? How many nodes are red? 1, 2, 3, 4, 5, 6, 7, 8. So we need a way to know, to count how many nodes are. I'm gonna decrease my image. It's not that I'm like egolatristic or anything. I'm gonna decrease myself. This is me. This is me. I'm just trying to solve this thing. Okay. So now we're gonna do some serious programming here because we need to calculate some stuff here. This is a recursive function that is gonna count the sizes of each node. If the root is null, there's nothing to count. Now, we like a little bit of hacking here, so let's do hack. Let's do another map which tells us of. It's gonna give us parent of, right? This is like sort of like cooking in a way. You're just doing stuff and it somehow works. It's really cool. Okay, so if we get the info on the right child, if it's not null, as you can see here, if the right child is not null, get the info and then make sure that parent of the right node is me. Okay, so now add size plus equal size of root of my right child because I already have this information, and now size of me equals size. Okay, so it should work. Okay, so it should work in theory. This is my best count. So there are three possibilities. First, in this case I take the left child, and in this case I take the right child. And now return best count. So supposedly this should be the solution, but probably there's gonna be problems. So let's see here. Run code, compile problem. Okay, so now it's time to fix some problems. Okay, run code. It worked. It's working. Oh god, so this is all a bunch of code, but I'm thinking of an improvement. So now it's time to submit the solution. You know, it makes me nervous because if it's wrong, I'm gonna be like, oh my god, I hope it's not wrong because I'm tired and I hope it is not wrong. So what I'm gonna do is now is I'm going to submit this to when I submit it, it's gonna be run against thousands of test cases with huge input sizes and all type of crazy edge cases, all type of stuff. So let's see what happens. I'm gonna submit. Oh my god, here it goes. An hour of work. Here it goes, here it goes. Oh, wrong answer. Wrong answer, wrong answer. Let's try this one. Passing this test case. Okay, so now submit. Please release me from my suffering. Wrong answer. Oh no. Okay, so let me analyze this test case. For some reason now it's passing the test case. And I'm just gonna submit it. Please let this work. Ah, it works, it works, it works, it works, it works. Accepted, accepted. It's accepted, and it's good. I did it. Uh, I this is why problem solving is awesome. Like I have been struggling for like an hour, and this problem is like the thing is that the solution to the problem I got it, but the thing is that the coding it uh, was made really hard by the fact that they don't give you the enemy as a pointer. They give you the enemy as the value of that node. So that changes everything. But oh my god, what a relief! It works. Um, it's another map. Okay, so let's go through the code. I create 3 maps. Set maps just clears all the maps. Clear. And then get info. This function is the most useful one. And the max count. This tells me the best result that I can have. This is the best result that I can have. I start with 0, and then this works, and submit, and it's gonna be accepted again. I just like it. It was accepted, and it could be much better. It could be much faster if I make these maps as arrays. Um, that will be a good optimization, but I'm not gonna go there. So thank you guys for watching this, and I'm going to keep solving problems. And if you like the video, give me a thumbs up, and if you like the videos in plural, subscribe to the channel. YouTube is gigantic, and it's pretty awesome, but it's gigantic. And if you lose a channel that you like, that happens very often. It happens to me, which is why I rather subscribe to something and then unsubscribe than not subscribe and then later regret it. So anyway, long explanation to subscribe. All right. So problem solving on Saturday. Uh, all right. Goodbye, guys.